Hey guys, my name is Lindsay and today we're going to take a look at the law of logarithms. But before we do any of that, I just want to go back to the basics in logarithms. This is something hopefully you've seen before already, but I just want to clarify a little bit for you. So here we have y equals b to the power of x. That's exponential form, values with an exponent. But we can write any value with an exponent in it as a logarithm. So I've kind of got that written here. B is the base. So if I'm going to write that as a logarithm, that's going to go below the word log as your base. This y value sitting up front is going to be beside that. And the exponent sitting up by itself right here is actually going to be the answer. And that's the reason that we have logarithms, because I'll give you an example. Let's say that 25 equals 5 to the power of x. Now, you can guess what 5 to the power of what equals 25, but what if this was a value you couldn't deal with, you couldn't just come up with on your own? If we write that as a logarithm, we're able to solve that. So instead of writing this like this, 25 equals 5 to the power of what, if I want to write that as a logarithm, I'll write it down below so you've got a little bit more room. I could write log, and then the base is what is sitting under the exponent, so that would be log base 5. And then after the base, I'm going to write this answer, log base 5 of 25, and that whole thing equals x. So now, if you're comfortable with solving a logarithm, or if you wanted to use your calculator, you could find what log base 5 of 25 is, and you'd find that the answer, in this case, is 2. But it gives us the opportunity to solve for a variable when the variable is up in the exponent. So that's why we use logarithms a lot of the times in math. And there are quite a few laws of logarithms. We're just going to focus on the first three of the laws of logarithms, and they actually relate to the laws of exponents, because when you look back here, here is this written in exponential form and written in logarithmic form. You can see the relationship. These laws have a relationship as well. So let's take a look at the laws of exponents first. I've got b to the power of x times b to the power of y. B, it just means that this base is the same. It doesn't matter what number it is as long as it's the same. And if I'm multiplying, my answer is the same base, but I would add those two exponents. And I'm hoping at this point that's something that you know already. B to the power of x times b to the power of y is just b to the power of x plus y. So I'm adding those exponents. And the way that that transfers over to the law of logarithms, here I've got log base b of x times y. If I wanted to expand it over here, multiplying went with adding. That same thing happens here too. So I could rewrite this as log base b. That wouldn't change, but I could have the x, and I could add that to log base b of y. And that's called expanding a logarithm. So I have one log there, and I've got more than one. I've got two in this case over here. And hopefully that makes sense, that those two laws are actually related to each other. Let's take a look at another one. So I've got b to the power of x divided by b to the power of y. And what I hope, again, you know already is when I'm dividing, I subtract exponents. So I'm going to write x subtract y in that situation. So over here, it translates again. I'm going to write log base b of x, because that's on top, subtract log base b of y. So again, that allowed me to take one logarithm with more than one variable in it and expand it into multiple logarithms. Last rule we'll look at in this video is this one down here. B to the power of x in a bracket, and then y on the outside of the bracket. So again, hopefully you know that what I would do with these two variables is I would multiply them together. X times y. Translates a little bit differently over here. I've got log base b x to the power of y. What I can do, which relates to this, is I can take that y and I can pull it out front of the whole logarithm. So log base b of x to the power of y is the same as y times log base b of x. So hopefully that relationship between the laws of exponents and the laws of logarithms makes sense because of the relationship between exponential form and logarithmic form.